For anyone shopping for toilet paper recently, the last few months have made it clear what can happen when our supply chains aren't operating effectively. What's perhaps less clear is that even during normal times, huge inefficiencies exist in our commercial supply chains. Companies consistently lose money as a result of failing to meet demand. They can incur big costs as a result of holding stock unnecessarily. Transport bottlenecks can create delays. And on top of all this, there is, of course, the waste associated with unsold products. This inefficiency is not just a result of poor data or poor forecasting. Much of it results from suboptimal decision making. This failure to make the best decision given the information available can cost businesses anywhere from 5 to 10% of their revenue per annum and cost the Australian economy in the order of billions of dollars each year. To help address this, we have designed a new type of AI algorithm. It is based on similar principles to the famous algorithm which Google recently used to beat the world champion at the board game Go. The idea is to treat managing a supply chain like playing a board game. Using the algorithm is simple. A simulation of some part of a supply chain is constructed. Our AI is trained using this simulation. Once trained, the AI can respond to the state of a supply chain by creating instantaneous recommendations regarding what immediate actions to take so as to maximize longer-term profit. Current state-of-the-art algorithms in this area have well-known limitations, including huge computational cost. It's estimated to have cost Google tens of millions of dollars just to train their Go playing algorithm, making it ill-suited to solve practical, real-world problems. Our key point of differentiation is our technology, for which we are currently in the process of obtaining IP protection. It is designed to be faster and cheaper than existing approaches, making it far more practical for industrial application. The team is comprised of myself and Jonathan. We are two data scientists with over 20 collective years' experience applying emerging technology to business problems, and we are both active in AI research. We conducted almost 70 interviews during the 8-week TRAM track course with interviewees from 10 different countries. In conducting our interviews, we were looking for potential customers which satisfied 4 key criteria. They need to have a complex system to manage. Our technology won't help if a solution is too easy to find. There needs to be existing IT infrastructure which our algorithm can plug into. The problem needs to be common enough so that there are plenty of potential customers. Finally, and most importantly, there needs to be an appetite for better solutions. Using these criteria and the interviews we conducted, we were able to narrow our search down from a huge range of potential applications to inventory management, which is a sub-problem of supply chain management. Given it contains the most likely early adopters, this market will form our beachhead. We discovered very quickly in this process that it really matters who you talk to. As one example of this, at one point we spoke to several employees in a single company and were astonished at the differences in response we received. Operational staff would tell us that few efficiency gains were possible, whereas our value proposition immediately resonated with senior managers. This observation will be of great help to us as we plan our conversations going forward. We also learned by talking to existing service providers that our value proposition is not, in fact, unique. Indeed, 1 or 2 companies we talk to are already exploring using technology similar to ours. This may seem like a setback. However, on the contrary, we took this as critical validation that much of the groundwork around applying approaches similar to ours has already been done. Importantly, these same companies reported discouraging technical challenges applying state-of-the-art methods. To us, this points to a great opportunity for those wielding new and better technology. We have set ourselves a collection of rough milestones over the next 2 years. Our immediate priority, however, having already generated very promising results in artificial settings, is to start testing our algorithm on real-world problems. As a result of our interviews, we already have several leads to help us with this process. Moving forward, we'd love to speak to anyone interested in our technology. In particular, we're interested in people with a connection to supply chains or optimization in industry generally. That's all from us, and thanks very much for listening.